So last lecture incomplete example that eliminate f and form the partial differential equation from the equation f of u v is equal to 0. The formation of partial differential equation from this equation f of u v is equal to 0. F of u v is equal to 0. So differentiate with respect to x, with respect to y, and then multiplying by this bracket to equation 1, this bracket to equation number 2, and subtracting, we have this. Okay. And then the notation for the partial derivative, that dou by f by dou by u as small f small u at suffix, then same dou by u by dou by x as ux, dou by u by dou by z as uz, and all this. Dou by z by dou by x as p, dou by z by dou by y as q, and then multiplication of these two brackets. So what are the terms? We have the total four terms: ux vy, right? Ux vy, then ux vz q. So in the place of p, write q, then uz vy p, then uz vz pq, and the multiplication f of, cancel this f of u throughout. Then the multiplication of these two bracket, again we have four terms but negative sign, so write in bracket that vy uz vy, we have uy vx, then uy vz p, then uz vxq, right here uz vxq, right here q, it is not p, it is q. Then last term vz uz vz pq. Okay, so we have this right here uz vz pq is equal to 0. So right here q, uh, the multiplication of these two terms vz and u vxq, right here q. Then we have, after effect of negative sign, we have these terms minus uy vx minus vy vzp, and then vx v uzq, right here q, and the term is minus uz vzpq is equal to, and then this term uz vzpq, this minus uz vzpq become 0, and the remaining terms, so p, the coefficient of p are vy uz vy minus vy uz uy vz. This is this term, the coefficient of p. This is the uz ux vz ux vz vy, it is q, here write q, so vy uz, this term, and here is the term of p is uy vz uy, observe this term uy vz uy vz, right here uy vz, it is vz plus terms of q. So this is the term ux vz, right here p, ux vz minus this term, right here q. So here is q vx uj vx uz vx. Okay, so plus this term and this term get cancelled, so the remaining terms are ux vy minus uy vx is equal to 0. So this is the term p, and this is the Jacobian dava uv dava zy, dava uv dava zy is the determinant. Actually this is the determinant, dava uv dava zy determinant, dava u by dava z dava u by dava y, and dava v by dava z dava v by dava z dava y. Okay, so we have, this is the dava uv dava zy, and this is dava uv dava xz, This is the Jacobian, and this is the Jacobian WV xy. Then shift this term to RHS. It becomes minus WV xy, and accept that negative sign. That the instead of xy, write yx. So by shifting this term to RHS, we have negatives this term, and then WV xy is equal to minus of that, minus WV xy is WV yx. So as what we have, WV yx is minus WV xy. Then PWV, okay, we have this term, this as it is, and then PWV zy, WV xz, and WV xy, yx. Then if we change the sign of all these, then write here minus, 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 and accept that minus at this place. So we have PWV yz. Instead of zy, write yz. Then instead of xz, write zx. That is through negative effect. So write minus of this, minus of this, minus of this, and minus uv zy is plus uv yz. Then minus uv xz is plus uv zx, and minus uv yx is plus uv xy. That is change the sign of all the quantities. We have this, and this is the partial differential equation satisfied by f of uv is equal to, can be written as. So this is the partial differential equation of this equation. F of uv is equal to 0. Generate this partial differential equation. That is, f of uv is equal to 0 is the solution of this partial differential equation. Okay, so this is about the formation of partial differential equation. That is, the solution is given. This is f of uv is equal to 0 is the solution, and this is the solution of this partial differential equation. P uv yz plus q uv zx is equal to uv xy. That is, this is the partial differential equation. This is, then its solution is f of uv is equal to 0. The next example, z is equal to x into y plus f of x square plus y square. Z is equal to x plus y plus f of xy, x into y. So eliminate the function f from each of the following equation and form the partial differential equation. Again, the same type problem. We have to eliminate the function and we have to find the partial differential equation. First example is f of z minus x into y, comma x square plus y square is equal to 0. That is the differential equation of the form f of uv is equal to 0. F of uv is equal to 0. What is u? U is z minus xy, and x square plus y square is v. And we know that if f of uv is equal to 0, then the corresponding partial differential equation is this: p uv yz plus q uv zx is equal to uv xy. So if this is the partial, this is the equation, given equation f of u is equal to 0, then the corresponding partial differential equation is this. So we are given this f of z minus xy, comma x square plus y square is equal to 0. So if we denote z minus xy as u and x square plus y square as v, then it is of the form f of u is equal to 0. So find this is uv xy is the determinant u x by w by x, w by y, v by x, v by y. Okay, so this is the Jacobian. And then w by x is what? W by x is z by x, that is p, small p, minus Dabba x of x into y is y, because dabba x by dabba x is 1, minus then dabba u by dabba z by dabba y is q, and then minus derivative of x into y with respect to y is x, dabba y by dabba y is 1. Then dabba v by dabba x is 2x, because derivative of x square is 2x, derivative of y square is 0. Then dabba v by dabba y is 2y. And then after solving this determinant, we have p minus y into 2y minus q minus x into 2x. That is 2py minus 2y square minus minus 2qx plus 2x square. That is minus 2y square plus 2x square plus 2py minus 2qx. Okay. Similarly, dabba u by dabba uv dabba zx, the Jacobian dabba uv dabba zx is what? Dabba u by dabba z, dabba u by dabba x, dabba v by dabba z, dabba v by dabba x. And dabba u by dabba z, dabba u by dabba z is 1, because the derivative of z with respect to z is 1, and derivative of x and y with respect to z are 0. The derivative of x and y are independent variables. So, and then dabba u by dabba x, dabba u by dabba x, dabba u by dabba x is what? Dabba z by dabba x is p minus dabba u by dabba x is y, p minus y. Then dabba v by dabba z is 0, x square plus y square, v is x square plus y square, its derivative with respect to z is 0. And dabba v by dabba x is 2x, derivative of v with respect to x. And so we have it is 2x. Similarly, dabba uv dabba yz, dabba uv dabba yz, this quantity dabba uv dabba yz is what? Jacobian dabba uv dabba yz is equal to determinant dabba u by dabba y, dabba u by dabba z, dabba v by dabba y, dabba v by dabba z. And dabba u by dabba y is what? Dabba z by dabba y, that is q minus x, q minus x. And dabba u by dabba z is 1, because derivative of z with respect to z is 1, and derivative of this x into y with respect to z is 0. And then dabba v by dabba z, v is x square plus y square, is derivative with respect to z is 0. Okay, 0. And then we have the determinant, this into this is 0, q minus x into 0 is 0, minus 2y. So minus 2y is the determinant. Then from equation 1, substitute all these values in equation 1. Then p dabba u v dabba yz is 2, is a minus 2y. Then p in bracket minus 2y. Q that dabba uv dabba zx is what? Is 2x, is equal to dabba uv dabba xy. Dabba uv dabba xy is this, minus 2y square minus 2 in bracket x square minus y square plus 2py minus 2qx. And then we have minus 2py, and this minus 2py becomes minus 4py, and this 2qx, and this become plus 2qx becomes 4qx is equal to 2x square plus y square. Dividing throughout by 2, we have 2qx minus 2py is equal to x square minus y square, and which is the required partial differential equation. That is, this is the partial differential equation whose solution is f of z minus xy comma x square plus y square is equal to 0. So this is the solution, and we have to find its corresponding partial differential equation. So in the next topic, this is given that the function, this is given that 2qx minus 2py is equal to x square minus y square. This is given. That is, this is the given partial differential equation, and we have to find its solution. So its solution is of this type: f of z minus xy comma x square plus y square is equal to 0. So in the next topic, this is the problem that 2qx minus 2py is equal to x square minus y square, and its solution is this: f of z minus xy comma x square plus y square is equal to 0 is its solution. So next problem is for homework, that f of x into y comma x plus y minus z is equal to 0. So same procedure, uh, denote x into y as u and x plus y minus z as v, denote x u n, and write this equation that p w by w v w y z plus q w v w z x is equal to w v w x y, and find all these three Jacobian, substitute the values, and we get this answer: x in bracket p minus 1 plus y in bracket 1 minus q is equal to 0 is the corresponding required partial differential equation. That is, this is the solution of this partial differential equation. So this topic is formation of partial differential equation. That is, we are given the solution of the partial differential equation, and we have to find the corresponding partial differential equation. So this is the solution actually, and this is the corresponding partial differential equation. So next example, z is equal to f of x into y by z. So it is not of the type f of uv is equal to 0. So we have to form the corresponding partial differential equation. So differentiate with respect to x and y. So the step is what? Differentiate this equation with respect to x and y. We have to eliminate this s small f. So we have dabba z by dabba x as the derivative with respect to x, dabba z by dabba x, that is small p, is equal to f dash xy divided by x into y divided by z into derivative of x into y by z with respect to x. So now y is constant now. With respect to x is the derivative, so y is constant, and the derivative of x by z. Z is the function of x and y. So derivative of x by z by using u by v rule. Z derivative of x is 1 minus x. Derivative of z is dabba z by dabba x divided by z square. Y is constant. So we have f dash x into y by z into y z minus xp, dabba z by dabba x is small p, divided by z square is the dabba z by dabba x, that is small p. Similarly, differentiate with respect to y, we have dabba z by dabba y, that is q is equal to f dash x into y by z x in bracket derivative of y by z with respect to y is what? Z into 1 minus y dabba z by dabba y divided by z square by u by v rule, and this is f dash x into y by z into x in bracket z minus yq divided by z square, equation number 2. So if you observe the RHS of equation number 1 and 2, then we have to multiply, we have to eliminate this f dash or f. So dividing 1 and 2, just divide 1 and 2, we have p by q is equal to. So how we can eliminate this small f or capital F, that function, from 1 and 2? That is, differentiate with respect to x, with respect to y, equation 1 and 2, and in order to eliminate the function, either subtract the two equations or add the two equation or divide the two equation, multiply the two equation, or multiply equation 1 and 2 by any quantity and subtracting, adding, we have the answer. So here we divide the first and second. So p by q is equal to f dash x into y by z into y z minus xp divided by z square, and f dash x into y by z x in bracket z minus yq by z square. So we have f dash x into y by z becomes 0, and then y by x and z square get cancelled. So z minus xp divided by z minus yq, and that is p. We have px z minus yq is equal to yq z minus xp. That is pxz minus pxypq is equal to yqz minus xypq, and then minus xypq and minus xypq of both sides get cancelled. So we have z in bracket px minus yq is equal to 0, and this is the corresponding partial differential equation. So the solution of this differential equation is this: f of z is equal to f of x y x into y by z. Then next example, z is equal to f of x minus y. Okay, and we have to form the partial differential corresponding partial differential equation. So solution is given, and we have to differentiate with respect to x and y, equation 1 and 2, and from equation 1 and 2 eliminate this capital F of the function f. So first derivative with respect to x, d by z by d by x, that is p, is equal to f dash x minus y into rate of x minus y is with respect to x is 1. Then d by z by d by y with respect to y derivative is q, and it's f of x minus y into derivative of x minus y with respect to y is minus 1. Derivative of x is 0 and derivative of minus y is minus 1. And then dividing 1 and 2, we have p by q is equal to minus 1. And so p is equal to minus q, and we have p plus q is equal to 0. Either dividing 1 and 2 or adding 1 and 2. P plus q is equal to minus, this is f dash x minus y, and this is minus f dash x minus y, become 0. So p plus q is equal to 0. Either dividing 1 and 2 or adding 1 and 2, we have p plus q is equal to 0 as the corresponding differential equation. So this is the partial differential equation. P plus q is equal to 0 means d by z by d by x plus d by z by d by y is equal to 0, and its solution is this: z is equal to x minus f of x minus y. The z is equal to f of x into y. So differentiate with respect to x. So small p is d by z by d by x is equal to f dash x into y into derivative of x into y with respect to x is y. Then q, that is d by z by d by y, is equal to f dash x into y, and derivative of x into y with respect to y is x. So equation 1 and 2. And then dividing 1 and 2, we have p by q is equal to y by x. Or multiplying equation 1 by x and multiplying equation 2 by y and subtracting, we have px minus qy is equal to 0. Okay, this is the corresponding partial differential equation. Then next example, lx plus my plus nz is equal to phi x square plus y square plus z square. Obviously, we have to eliminate this function phi to form the partial differential equation. So phi x square plus y square plus z square is equal to lx plus my plus nz. That is differentiate. What is the procedure? Differentiate with respect to x, y, z. Now there are three variables. Differentiate. There are only differentiate with respect to x and y. Equation number 1 and 2. And from equation 1 and 2, you have to eliminate the function phi by adding, subtracting equation 1 and 2, or dividing 1 and 2. Equation 1 and 2. So differentiate with respect to x. So phi dash, derivative of phi is what? Phi dash x square plus y square plus z square into derivative of x square plus y square plus z square with respect to x is what? Derivative of x square is 2x. And derivative of y square is 0 with respect to y. Derivative of z square is 2z into d by z by d by x. 2z into d by z by d by x. Plus derivative of lx is l plus my derivative is 0. Derivative of nz is n d by z by d by x. Okay, then d by z by d by x is 1, is small p. So 2, this is what, take 2 as common, x plus this x plus z p, and this is f phi dash x square plus y square plus z square is equal to l plus np, equation number 1. Then differentiate equation this with respect to y. Now this equation star with respect to y. So phi dash x square plus y square plus z square into derivative of x, this bracket with respect to y, derivative of x square is 0 with respect to y, derivative of y square is 2y plus derivative of z square is 2z d by z by d x. Because remember that x and y are independent variable and z is the function of x and y. So z is derivative of z square is what? Z is the function of x and y. So derivative of z square as with respect to y is 2z d by z by d y. And the derivative of z square with respect to x is what? 2z d by z by d by x. But the derivative of x is with respect to y is 0, and the derivative of the terms of y with respect to x is 0. Because x and y are independent variable and z is the function of x and y. Is equal to the derivative of this quantity lx is 0, my the derivative is m, and the n d by z by d by y, that is q. Okay, and then substitute this d by z by d by y as q. We have this, and then Dividing 1 and 2 we get, 2 pi dash x square plus y square plus z square in bracket x plus zp, and 2 pi dash x square plus y square plus z square y plus zq is equal to lp l plus np divided by m plus nq. And then this phi dash term get cancelled and 2 get cancelled. So x plus zp divided by y plus zq is equal to n l plus np m plus nq, and then cross multiplication we have this. After simplification we have this. So we have this after taking x as common, m plus np minus y as common, l plus zq minus y, the term minus y, l plus zq plus z pm minus lq. Okay, because in terms of y, all the terms are y are negative, and plus z, the terms of z, it's pm minus lq is equal to 0. So this is the corresponding partial differential equation. So solution is given and we have to find the partial differential equation. So the next problem is again the solution is given, f of uh, x into y into z, comma x plus y plus z is equal to 0. So this is the problem of the type f of uv is equal to 0. So there are two types problem. F of uv is equal to 0, then use the standard formula. If f of the problem is of the type f of uv is equal to 0, then use the standard formula. And if the problem is of the type z is equal to the function of x into y, function of x, y, z, so then use the procedure that differentiate with respect to x, differentiate with respect to y, equation 1 and 2, and from 1 and 2 eliminate the function that f, small f, or pi, or small capital F. Okay, but this is the problem of the type f of uv is equal to 0. So denote this x into y into z as u, x plus y plus z as v, and then the formula to determine the solution is what? Is p. This is the formula. If the problem is of the type f of uv is equal to 0, then formula is this, that p dabba uv dabba yz, that is if f of uv is the given equation, then the corresponding partial differential equation is this, p dabba uv dabba yz plus q Jacobian dabba uv dabba zx is equal to dabba uv dabba xy. So the problem is of the type f of uv is equal to 0. So find all the three Jacobians. The p dabba uv dabba yz. The first find dabba uv dabba yz is determinant dabba u by dabba y, dabba u by dabba z, dabba u by dabba y, dabba v by dabba y, and dabba v by dabba z, dabba v by dabba u by dabba z, and dabba v by dabba z. So dabba u by dabba y, dabba u by dabba y is xz, dabba v by dabba y is 1. Then dabba v u by dabba z is x into y, dabba v by dabba z is 1. And then we have xz minus xy as this determinant, the Jacobian. Then Jacobian dabba u v dabba zx is what? Dabba u by dabba z, dabba v by dabba z, dabba u by dabba x, dabba v by dabba x. Either write this as a determinant or write dabba u by dabba z, dabba u by dabba x, that is this place, and then dabba v by dabba z, dabba v by dabba x as the second row. We have the same answer, x y minus yz, because dabba u by dabba z is x into y, dabba v by dabba z is 1, dabba u by dabba x is yz, and dabba v by dabba x is 1. So we have x y minus yz. Then dabba u v dabba xy is equal to dabba u by dabba x, dabba v by dabba x, and dabba u by dabba y, dabba v by dabba y. And then again dabba u by dabba x, because u is x into y into z. So dabba u by dabba x is yz, dabba u by dabba y is xz, and dabba v by dabba x and dabba v by dabba y both are 1. So yz minus xz. And so therefore the required partial differential equation, corresponding partial differential equation is what? Small p dabba uv dabba zx, that is this term, xz minus xy, xz minus xy, this term. Then plus q dabba uv dabba zx, right? That first formula. So it is xy minus yz is equal to dabba uvx dabba xy is what, yz minus xz. So this is the final answer, the corresponding partial differential equation, required partial differential equation. So these are the problems of formation of partial differential equation. So formation of differential equation by eliminating arbitrary constants. Again, the same type problem. We have to eliminate the arbitrary constants and we have to form the partial differential equation. So these are again the same type problem. So we will see these problems in the next lecture. Again, the same type problem. If the it is of the type z is equal to, then differentiate with respect to x and y, equation number 1 and 2, and then eliminate that arbitrary constants from the partial differential equation, from the equations, equation 2 and 3, or 1 and 2. Okay, so we'll see these problems. Here is the elimination of the function. Yeah, if you observe this problem, z is equal to f of x into y, or z is equal to uh, f capital F x minus y. Okay, here is the elimination of the function small f, capital F, or phi. Now the same type problem, but we have to eliminate here these problems. If you observe, the z is equal to x plus a, y plus b. So this problem having two arbitrary constants, small a and small b. So we have to eliminate that arbitrary constants. That is either eliminate the function or eliminate the arbitrary constants. So if there is only one arbitrary constant, then differentiate only with respect to x. So here the two arbitrary constants a and b. So differentiate with respect to x and y and eliminate that constants by adding the two equations or subtracting the two equations. So we will see the remaining problems in the next lecture.